This is the fourth of 4 videos that I've made for solving trig equations. If you haven't seen the first 3, I'd recommend that you go look at those. They're going to have a lot of details that I'm not going to do in this particular video. In this video, we're going to solve 2 equations, but we're only going to do the first step. In particular, we're going to go through some steps that you'll need to do to isolate the trig function. In this first problem, what I see is that I have an equation that has both the sine and the cosine of x, along with the sine of x on the right hand side, and that kind of worries me if I think about how I've isolated trig functions before. I can't just add or subtract sine or cosine to both sides to get one of them by itself, because I'm always going to have the other guy hanging out with it. So first thing that I'm going to try here is simply to get all my sines on the same side. I'll subtract the sine of x from both sides. That will give me the sine of x plus the cosine of x is equal to 0. And when I think about what this equation means, for two things to add up to 0, they have to be opposites. That is, the sine of x must be the opposite of cosine of x. I could subtract cosine of x from both sides to go from here down to here. This statement makes me think of something a little bit different as well. If I wanted to get a trig function all by itself, I could divide both sides of the equation by cosine of x. So I'd have sine of x over cosine of x is equal to minus cosine of x over cosine of x. And that corresponds to when the tangent function of x is equal to minus 1. Sine over cosine is tangent. The opposite of cosine over itself is negative 1. And both of these statements give me an idea of what I can do. If I think of the unit circle, the sine of x is the opposite of cosine of x, corresponds to two locations here and here. It's where my y value is equal to the opposite of my x value. Tangent of x is negative 1 is also at those two locations. So from here I can go through the normal steps that I've used in the previous 3 videos to solve for all the values of x that will be my solution set. For this next equation, I see another problem here that I haven't had to deal with before, and this one is going to seem a little bit bigger than the last problem. Biggest problem here is that I have not just two functions, sine and cosine, but the arguments are different. And I really don't think I have a chance at solving this equation until I get these guys to match. So the thing that I can do here is to notice that 2x doubled is 4x. So this is the sine of 2x plus the cosine of 2 times 2x. And that will still be equal to 1. And once I do that, what I can use is one of my double angle formulas for a cosine. So this is the sine of 2x plus the cosine of 2 times something. In this case, that something is 2x. And I need to think carefully about what formula I want to use, because there's actually 3 formulas for the cosine of a double angle. And the thing that's going to guide me here is that I want to end up with sines of x, and I do not want to have cosine of x. I'd like all my functions to be the same. So knowing that I've got the sine of 2x here, what I'd like to do is turn this into the sine of 2x if at all possible. So the cosine of 2 times theta is 1 minus 2 sine squared of theta, where my theta in this instance is 2x, and then that will be equal to 1. So what I've done here again is I've used the double angle formula for cosine, where I've got 2 times the angle 2x. At this point, what I notice is that I have sine to the first power and sine to the second power, along with some constants. So this is actually a quadratic form. And to solve a quadratic form, I always want to get everything equal to 0. And then if I can factor things, I'll consider myself lucky. So I'll subtract 1 from both sides. That will give me the sine of 2x plus 1 minus 1 is 0, minus 2 sine square of 2x is equal to 0. And fortunately this factors. If it didn't, I would fall back on using the quadratic formula, which would be just as good, but it would take a couple more steps. So to factor this, I have a common factor of sine of 2x. I'll factor that out. Sine of 2x times be 1 minus 2 sine of 2x is equal to 0. And then from here I can use the zero product property, and I'll actually end up with two different equations. If I set this first factor equal to 0, I'll get the sine of 2x is 0. And if I set this factor equal to 0, I'll get 1 minus 2 sine of 2x is equal to 0. Once I've done this, this equation I've actually isolated sine. Over here I would still need to subtract 1 and divide by negative 2. So I'll have the sine of 2x is, so this will be negative 1 divided by negative 2 is 1/2. So I've isolated my sine function in both instances. I would solve both equations, and from there I would get my solution set.